Hey guys, how's it going? You asked me to go on with my short series about how to write a microservice from scratch in Java. And today I will show you how you can add dependency injection to our existing service. So here we go. If we want to add dependency injection to our microservice, then we have to change several things. And let me start with the dependencies in the POM file, because when we started our microservice from scratch project, we have chosen the Jersey runtime, and the Jersey runtime is modular, and one of the modules is good for the fact that Jersey needs to inject things at runtime. This has nothing to do with what we want to do today, but it is using a dependency injection framework internally. And this framework is HK2, which is from the Glassfish world. In the first steps, we will use CDI to do our injections. So it makes sense that I change the Jersey's internal use of dependency from HK2 to CDI2. And I will do this here, which is rather easy. And by doing that, we will gain something on the class path and dependency tree. And I will show you what the class path looks like. So in a few seconds, we will see that we gain some neat things. For example, where it is, we should have it Jersey core CDI2 is here. And here you see that by switching to CDI2 inside of Jersey, we now have weld on the class path. And this is nice because weld is the CDI reference implementation, so we don't have to bind it manually here as a dependency. Certainly you can do that, but I just want to show you this. This is a small trick you can do because you now have weld. There is no need to explicitly add it on the class path. So having done that, let's go into our Java application and see what we further need to do to be able to use dependency injection at the level of the application itself instead of the level of Jersey. One thing, by the way, weld is not starting up unless you provide a beans XML file, as you can find in the standards document of CDI. And I don't want such an empty file. I think it's a strange idea to have an empty file on the class path. So what I'm doing is another way we can enable weld, which is setting a system property. So from my view, this is nicer, but you also could instead add a bean XML file. In fact, I just started to make it run once. You can see it works. In fact, in the further steps we are doing today in this video, I actually will add a beans XML file. I just wanted to tell you this small trick. Unless you really need to modify the beans XML file, you don't need it. You just can add line 18, copy it from your screen, and you can enable CDI by that. So if I click here, then yeah, my code still works. This is what we expect. We don't have actually changed anything. We just told Jersey internally to use weld and CDI API instead of HK2. So now we're coming to the steps what to do in our application with dependency injection. One thing we could do with CDI, for example, is that we don't want to have static code here in our resource which is creating a new instance of this class statically. By a more flexible solution, we want to introduce a factory, and the factory implements an arbitrary algorithm. In our case, it's the same algorithm. We just have this more level of abstraction. It's all about showcasing injection. And this factory shall not be hard-coded here in the resource. It shall get injected. This is really a typical pattern what you want to do with dependency injection in JAX-RS. So we want to write inject here, service a big I, and we have here a public greeting factory here, and this one is getting injected every time the greeting method would be called, because in that case a resource is called, because the default scope, so what is scope? It's the lifetime of a resource in JAX-RS is actually per request, which means each HTTP request will create a new instance whenever any of the HTTP methods is rooted inside it. So we need a greetings factory. So let's write a greetings factory, public static. Let's make it static class greetings factory. Yeah, factory. And this one has a method public create greeting, and then there will be a message, and the code is the same. We create a new greeting. It's just for understanding how to work with injection. So here is the factory, and the factory creates a greeting with a message. And the message is also called greeting. We have greetings everywhere. So paste it here. So now we have one more level of abstraction. We get injected a factory. The factory is producing a greeting from this message by simply doing what it did before. We need a return here and a greeting here. This one is called message. Now the strange thing is we cannot compile because it says I don't know what inject is, and because there's a typo, obviously. Greetings factory. No, so this one was by intention. Why is that? You always hear JAX-RS and CDI in the same sentence, and it's even together in Jakarta EE side by side. In fact, they don't have much to do with each other. They're a separate, standalone, sovereign specifications or APIs. So if we want to use CDI, then we have to tell it in the dependency. Now, you would say we just told it in dependency. No, actually, we did not. This is something which is hard for beginners to understand. We just told Jersey to internally use CDI. And Jersey is just the implementation of JAX-RS. And as you can see here, this dependency is only pulled in at runtime, which means after the deployment. But we are even prior to compilation here. We actually want to compile, not to deploy. So we are in the compile scope of Maven. So we need something that tells us that we can use dependency injection. And this clearly is another dependency we have to add. So we should go somewhere here and provide a new dependency which is only used at compile time to tell our tools like the compiler or the IDE that actually we can use the annotation inject. And this is not too complex. In fact, it's a bit to type, so I paste it from the website. You can find that actually on the websites of dependency injection and CDI. What's the difference? By the way, dependency injection, which is this dependency, dependencies everywhere, this provides the inject word. And CDI provides scopes. We don't have scopes yet. We will add it in a few seconds. And to make it work, we need to add the versions here. I always go with properties for versions. It makes it easier to check the versions or to update them without scrolling through all the files. So that's my personal thing here. I like it this way. So save. Okay, I wanted to show you scope. So we have the quick fix. Add all missing imports. So now it's happy. So we don't have a scope yet. If you check the CDI tutorials or the specification, you certainly understand what a scope is. Just in short, it's the lifetime. The injection framework needs to know when to create and destroy instances. So how long shall they live? And what we want to do here is go with, for example, an application scoped instance, which means this instance will get created together with the application, and it lives as long as the application lives, even if the resource is destroyed already, and even if the request is destroyed already and there's no session anymore and all that, the application still is running. So this instance will live. As you can see, this is not a full CDI tutorial. I just want to show you how to use CDI to get dependency injection, to use it in your microservice. I really would agree that you need another tutorial about all the CDI features and all the scopes and all that if you want to go into production with this. Completely understood. This video is solely about how to add it to your JAX-RS microservice. So now we have the two dependencies in place, so we can use add inject and we can use application scope. Okay, if you don't know what add inject is, it tells the dependency injection framework that we want to have an instance of Greetings Factory injected here as soon as this object is created, and this object is created by Jersey using internally an injection framework, which is CDI, which is what I told you in the start of this video. Wow, it's a bit complex actually. Maybe I should draw a picture next time. And the or the injection framework in our case is CDI, and CDI's implementation is by our choice Weld. So I hope it makes sense to you. Okay, so we have everything in place, so it should work actually. Let's see if we can start it. Yes, we can. But you see, it needs rather long time here. I don't know if you have noticed it. Let me start it again. The prior starts were a bit faster, and now it needs rather long time here at that step. And in case you wonder why that is, then I will show you a trick. So first first things first, it's still working. It's great. We have CDI working, which means we have dependency injection working with weld. You can see it here. Okay, so why does weld need time here? The point is that stuff with dependency injection is working heavily by inspecting your compiled code. So it needs to find out about all these annotations. Now you would say, what's the problem? I have a greetings factory and I check the class for annotations. Well, it's not the case. The case actually is that the dependency injection framework needs to know what classes are there. So it needs some kind of discovery. It needs to learn, are there classes having any annotations? Are there classes that are eligible to get injection? There's a lot of questions CDI has to answer before it knows the big picture, what you want it to do. And this is all going by the Reflection API. And if you have ever worked with Reflection API, yes, I know it's much faster than it was in the past, but it's still slow. So as Reflection is slow, you have this waiting time. Now, please don't say, whoa, what a crap, I don't want to use CDI. No, please, that's not a problem of CDI in general. That's a problem of Reflection. So if we could choose a different solution by not going with Reflection, then we can solve this. And there is a solution, and I will show you. In the case of weld, we can add an additional dependency, which I want to do now. And it is called Yandex. And what Yandex makes is Yandex is providing an index. Let me add it first to the correct scope. We need the runtime scope, and let's start it. And while it's starting, we can see that it now says it is using Yandex for bean discovery, and still it needs a few seconds here. So it's not really perfect, but it's faster than without Yandex, in particular if you have lots of annotated CDI beans. Okay, what does index means? Yandex is scanning all the classes on the class path for all their annotations and has an index inside of the main memory. So each time weld is asking for classes with specific annotations, or if it needs the answer, I have an annotation which class has that, or queries like that, weld will not check live the loaded classes. It will check Yandex, and Yandex can provide these pre-computed answers much faster. The problem in my example is I only have very few classes, so you don't see a big difference. If you want to see a big difference, you must use bigger projects, or, and this is trick number 2, we do not create the index at the program start, which is needing some time here. You can see it here, it needs time to create the index. But we can create the index at build time, and that's an interesting solution, because if we have the index provided at the build time, then at runtime we don't have to build the index, so it should be faster to load. And this is what I would recommend always when you go with weld. Always create a Yandex index at build time. It doesn't need much more time to build, but it will be much faster when loading. So let's change this code. What we need to do is to add to our plugins section, this Maven plugin. So this is not a dependency, it's a Maven plugin. It actually does the same as Yandex does at runtime, but it does it at the compile time. It processes all the classes and creates a file holding all the information in already resolved and easy to understand way for Weld, containing the information which class has which annotation in core. So as it runs once at the build time and provides the final information, the startup should go much faster. So let's try it out. Let's build our project. We do a clean package. Sorry guys, I know, never do ambient clean package. I know. I just do it for safety because I did a lot of experiments earlier today, so I really want to have a safe place to start with. We have a shaded jar here, and we go with Java jar target cdemo. You would wonder why I'm not going with this one, because this is renamed on my disk. So the shaded jar now actually is called cdemo1 jar. This is what Maven does, actually, even if not writing here. So we started, and let's see what happens. It says it, yeah, it's here. It was a bit fast. You see Yandex here, and you remember it needed long time here to create index. So let's do it again. We started, and there is literally no waiting time. It really starts up within very few time. Let's see, in 1 second, from 17 to 18. It needed really 1 second. Yeah, it's still working. Sure, let's test it. Test. So yeah, it's working. You might wonder if you can use this trick also if you are starting from within your IDE, and actually you could, because Yandex is still searching for the same file. You certainly could instruct your IDE to also run that Yandex pre-assembly of that file at time of compilation, and if you put it in the right location on disk, so your IDE can find it, it actually would pick it up. I don't have much experience with Visual Studio Code, so I can kind of tell you actually how to tell Visual Studio Code to do that, but I'm pretty sure it can do. I used a lot of such bundling steps in Eclipse in earlier times, so I'm pretty confident that your IDE is able to get configured in that way. Yeah, okay, so let's stop that. So now we have CDI in place with a pre-created Yandex index to start within 1 second at runtime, which is pretty great, but we're still not at the end with dependency injection. Okay guys, hope you liked this video as much as I did, and I would be happy if you give it a thumbs up, and it would be great if you would become my subscriber, or if you would donate a few euros or dollars so I can make more videos like this. That would be really great. Thanks in advance. So until next time, stay safe, and as always, party on!